Hey, what's up? It's Jordan here from Projectiles R Us. I've heard that you're looking for a cannon that can fire your clown. Well, we've got just the thing for your show. This is our prototype cannon that we believe is the perfect fit for you. How does it work, you say? Well, imagine a rocket lifting off. How does that work? Most people would assume that it's the exploding fuel pushing against the ground that causes the rocket to lift off. But that's not true at all. This is wrong because the propulsion of the rocket isn't actually dependent on the fuel pushing against the ground. It actually refers to Newton's third law, which says that every action has an equal and opposite reaction. So, the exploding fuel accelerating downwards out of the exhaust causes the rocket to accelerate upwards. Now you might be asking, what does this have to do with the cannon? Well, let me show you. This is our prototype. Inside this chamber, there's a fuel explosion. The fuel that accelerates this way causes the cannon to roll back, and the fuel that accelerates this way causes the equal and opposite reaction of the ball accelerating that way out of the barrel. These two action-reaction pairs are the primary reactions inside of our prototype. Now I still haven't told you exactly how our cannon works. What happens inside of this cannon is known as a combustion reaction. What is combustion? Combustion is the near instantaneous combination of a substance with oxygen producing heat and light. This is the balanced chemical equation of our combustion reaction. Let's give you a little example of exactly how this cannon works. Step 1. Heat the cannon's combustion chamber for about 5 minutes with a high-powered blow dryer. Step 2. Insert the tennis ball projectile into the barrel and ensure a snug fit, not too loose, but not too tight. Step 3. Measure 2 milliliters of methyl hydrate and add to the cannon's combustion chamber. Step 4. Shake the cannon for 2.5 minutes while keeping the fuse hole covered. Step 5. Make sure the base is properly positioned. Carefully hold the flame over the fuse hole and remain at a safe distance. From our observations, our most superior mathematician deduced the velocity of the base as it kicked back. From this we were able to determine the momentum of the base. We know that momentum is conserved, so we divided the base's momentum by the mass of the ball. This gave us the velocity that the ball exited the barrel at. We then used this velocity in combination with some simple kinematics formulas to determine the x displacement of the ball if the cannon was fired at a 20-degree angle. The standard deviation for our cannon is 7.1 meters. This means that our cannon, when fired at 20 degrees, should launch the projectile to a distance between 0 and 13.51 meters. We've shown that our cannon works. Now it's time to prove that it will work for you. We've determined the exact size of a scaled-up model, and it's reasonable. About 0.38 meters in diameter and about 2.5 meters long. This isn't too hard to construct, and it wouldn't require that much fuel to launch the clown either. It would only take about 2 liters for it to go the same distance as our test projectile, and it would only take about 9.5 liters for the clown to go a full 30 meters. On behalf of Projectiles R Us, I thank you so much for your time. I hope that with this information, you'll be able to make the right decision on what cannon is the best for you.